the last lesson, I think we did these examples, and these are all the formulas we've learned. We use the complementary identity, the reciprocal identity, and the ratio identity, Jeremy. So there's lots of formulas, only 4 which are on the formula sheet, so make sure you memorize them all, and by writing them out many times, and then you can memorize them. Okay, good. So today's lesson we're going to focus on angles, how to find sides, how to find angles. These are much easier to do. Let's go through this. So the first thing we're going to look at is, we know that the size of an angle is measured in degrees. In order to be more accurate, the size of an angle can be measured in degrees, minutes and seconds. So 1 degree is 60 minutes, and the symbol for minute is apostrophe, and 1 minute is 60 seconds, so the symbol for that is double apostrophe. Okay, so now we're going to convert the following into degrees, minutes and seconds form, so you can use your calculator. So in this section you need a calculator. If you don't have one, borrow one from me. Otherwise, take out your calculator. So we're going to convert the following into degrees, minutes, seconds form. So write down 27.53 and then press the degree button. See that degree button is this button there with a lot of apostrophe, this one there. Press equal. You get 27 degrees, 31 minutes and 48 seconds. 27 degrees, 31 minutes and 48 seconds. Right? And same thing for the next one, 114.8. Make sure you press the degree button, then press equal. Gives you 114 degrees and 48 minutes. Okay? Done. Alright. You can also go in the other way. So what if you want to change the degree, minutes, seconds into degree form? So what you press is 27 degrees, 45, the same button, minutes, 36 seconds. Okay? Equal. And press this button here, press the degree button again, so it becomes 27.76. So it becomes 27.76 degrees. Alright, so if I press that again, switch between degree minutes form and no minutes and degrees. Alright, so if you press that, that gives you form. Okay, good. What else I want to say? Now, what happens if you want to enter 30 minutes? What do? You still have to press 0 degrees, 30 minutes, right? Because it goes with place values. And if you press equal, you get half a degree, 0.5. And if you want to enter 30 seconds, you go 0 degree, 0 minutes, 30 seconds. Press equal. Yeah, so you get that. All right, so that's how you enter minutes and degrees. All right, any question? Let's move on to the next one. We need to be able to convert to the nearest degree. So obviously, if it's 0.5 or less, if it's less than 0.5, we don't round up. So this one's approximately 65 degrees because 4 is less than 5. If you get 5 or more, you have to round up, become 96 degrees. Now, different with minutes, because 60 minutes is 1 degree, half of 60 is 30. So if it's 30 or more, you have to round up. So you get 29 degrees. Note the difference between these two. This is 29 degrees, 45 minutes, but this is 0.47 degree, not 47 minutes. So we don't round up. See the difference between these two? Very different. Okay? All right, the last one we have to convert to the nearest degree. Again, you look at the minutes. That's 29 minutes, which is less than 30, so do not round up. So just write it like that. 55 degrees. All right, any question? Next, we're going to round to the nearest minute, then to the nearest seconds. Starting with nearest minutes, will be, look at the seconds. If it's less than 30, do not add anything. So you get 132 degrees, 33 minutes. If it's less than more than 30 seconds, you round to 195 degrees and 49 minutes. Yep. All right, good. Now, how about nearest seconds? Now, nearest seconds, we look at the point after that. And that point is 100. So half of 100 is 50. So that's less than 50. You have to round down. So it'll be 17 degrees, 28 minutes, and 27 seconds. This is not 30. You don't go up if it's 30 or more. You have to look at 0.5. These are in decimal. All right, go up by. So, okay, all right, good. How about the next one? This is 0.5 or more. So therefore, you have to round up, become 40 seconds. Right? 195 degrees, 48 minutes, and 40 seconds. All right, now we know how to round things. The exercise will be easy to do. All right, what do we do after this? We're going to look at some calculation question with the calculator. So all you have to do is just press 17 cos button, 34. You don't have to enter the degree sign. Just go like this. In fact, you don't even need a closed bracket. Just go 17 cos 34 equal 14.0, correct to 3 significant figures. So 14.1, 3 significant. Try the next one, and then the next one. Next one, just enter the fraction. So press the fraction key, 9 sine 23. Don't have to enter degree sign, over 5. But I think when it's a fraction, you do have to close the bracket, because if you don't, it gives you an error. So make sure you close the bracket. Okay, 0.73 on 3 significant figures. And the last one, you just have to enter again on your calculator. So you go fraction 27 over 5 tan 57 degrees, 23 minutes, 35 seconds, close bracket, okay? 3.45 to 3 significant figures. Okay. All right, good. Now, what if they want you to work out the angle? To work out the angle, you have to do what we call the inverse. This is read as sine inverse of 0.75. Sine inverse. That's how you read it, not sine to the power -1. Sine inverse. And to access sine inverse, you have to press shift sine. Press shift. See that sine inverse on the top where you see the yellow character? Shift sine. 0.75 close bracket gives you that. Correct to the nearest seconds. So press this to get the seconds and minutes and degrees. Okay. Let me rub this off. Oh. So you write sine inverse. Sine inverse. Inverse. Okay, good. So what you do is you're going to round to the nearest second. So 48 degrees, 35 minutes, and 25 seconds. 48 degrees, 35, 25. 35, 25. Like that. Okay. Now to do that, you have to press shift, sine. All right, next we have to do the cos inverse as well. So let's do cos inverse. So shift cos 14 fraction 31 nearest minute, nearest second. Okay, all right, good. So you just press shift theta is shift cos this. And what do you get? You get 63, 9, 10. 63, 9 minutes, 10 seconds. Double apostrophe. How about the last one? Now the last one, you need to get rid of the 5 first before you do the tan inverse. Then do shift tan. And then use your calculator. Calculator will say shift tan 3.35 over 5. 33, 49, 20. Okay? 33 degrees, 1949 minutes, and 20 seconds. Alright, hopefully it's all okay for you. Pretty basic, this one. How to round up, how to round down, how to calculate these basic calculations. So that's the essence of exercise 4.2. 6.2, say again. Except Anthony, he's overseas, he's somewhere else. Okay, so what you do is, we're going to move on. So the next section involves finding length and angles, so we're going to go through that. And then we'll do some challenge question on page 7. Okay? Alright, finding lengths and angles in a right angle triangle. These are very easy. And to do these questions, you need to use what we call SOHCAHTOA. Okay? Hopefully you still remember SOHCAHTOA. Alright. So example 14, we're going to find the length of BC and AC. BC and AB correct to 2 decimal places. So all you have to do is to label opposite, hypotenuse, adjacent. And in order to find out the opposite, you got O and H, which is sine. So you write sine 54 degrees is equal to opposite CB over 27. And to find out what CB is, you have to multiply 27 by sine 54 using your calculator. How do I know it's multiplied? Because if you multiply both sides by 27, the 27 gets cancelled. Like that. Right, using your calculator, you will get 27 sine 54, and that's easy. 21.84. 21.84 correct to 2 decimal place. CB, yep, is the line CB here. That's length, and then we're going to find AB. Let's find out what AB is. So to find AB, you have to use cos because A and H, SOHCAHTOA, CA. So you write CAH. So therefore, cos 54 is equal to AB over 27. Like before, multiply both sides by 27 to get the value of AB. So 27 cos 54. 54 cos 54, which is equal to 27 cos 54. You will get something. You get 15.87. All right. Any question? I forgot to put something down. Centimeters. All right. Any questions? All right. Try the next one. And then we'll find some angles and then some hard questions. Right, good. Try the next one. Next one a little bit different. You need to find the value of the hypotenuse, but the same process as before, opposite, hypotenuse, adjacent. So if I want to find the hypotenuse, what do? We are going to do this. So we're going to go sine again, sine 47, but this time will be 33 over AC. Okay, 33 over AC. So what you need to do is to multiply both sides by the denominator like before, but this time it's going to be a pronumeral you're getting rid of. And you have to do it in 2 steps. So AC is sine 47 is 33. To find AC, you have to divide 33 by sine 47 instead of times. So whenever you're finding an unknown in the denominator, you have to divide. So if you do 33 divided by sine 47, that will give you the answer 45.12. 45.12, correct to 2 decimal place. Like that. And similarly, find AB. Alright, we're going to find AB. So we'll do AB here. AB. How do we find AB? We're going to use tan to find AB. So tan 47 equal to 33 over AB. Okay, so, and then you can see AB tan 47 equal to 33. And then tan AB equal to 33. And then you use 33 over tan 50, tan 47, 30.77. Yep. It's correct. You could use Pythagoras, but I prefer to see, if you use Pythagoras, it's going to be more, not as accurate, because these are exact answer, isn't it? If you use Pythagoras, you're going to use this, which is rounded. So it may not give you this. Maybe we could. Does it give you? So if I go 33 square, the hypotenuse square 45.12 square minus 33 square, you get that, and then square root answer. Yeah, answer. Yeah, AB 45 minus 33 square. Yeah, that's what I did. Is that what I did? 33 over... Oh, 77. Yeah, so a little bit off. Okay, good. So 77. Oops. 77. Yeah, you're right. Alright, 77. Okay, good. You can use Pythagoras, but prefer to use the exact answer where possible. So from the above examples, we can make some conclusions. So we can find the other something of a right angle triangle if something and something is given. So what do we have to fill out in this? So from the above example, we can find the other two sides, right? So whenever I give you one side is given, you can find the other two sides if one side is given and one acute angle is given. Acute. One acute angle. So if you have a one acute angle and one side given, you can always find the other two sides using trigonometry, and provided that has to be a right angle triangle. Angled triangle. Okay? Okay, good. Any question? Let's find angles. Angles are a little bit easier. Let's do angles. So how do we do angles? So we'll just label the sides, opposite and hypotenuse. What do we get? Sine, right? So write sine theta equal to 9 over 17. To get theta, you go sine inverse of that. Is it near to the nearest degree? Nearest degree or something. I don't say, just our nearest minute. Alright, I'll get along with minutes, so let's just go nearest degree. Just takes too long. Okay. Alright, so just go shift sine 9 divided by 17. Nearest degree. Okay, 32 degree. 32 degrees, and do the same for the next. And then we'll do a harder example. So you get, the next one is opposite of adjacent, so you do tan. Theta is 14 over 22. And the same before, theta equal to shift tan 14 divided by 22, 32 degrees. Oh, they're all 32, okay. All right, let's do the next one. Hopefully it's not 32 again. So we get shift cos 24 divided by 14. Okay, so you get 14 divided by, that's what you get if you don't show working. All right, 54 degrees. All right, good, 54 degrees. All right, show your working. So you write cos theta equal to 14 over 24. Okay. All right, hopefully you can fill out the one bottom from the examples above. We can find the size of the something of a right angled triangle if something are given. What's the missing word? Find the size of the acute angle, right? Of a right angle triangle if two sides are given. Okay, of course the only word, oh, it's a right angle triangle. Okay. Actually, I don't need to write right angle. It's already written there. Okay. All right, we'll do two more harder examples, then we'll go through, then you can start the exercise. Harder examples. Next page. Harder examples, two triangles. Okay. In this question, you have to draw a diagram. Sienna built a slide at an angle of 41 degrees. Do a slide, that's a slide, to the ground. If the vertical ladder is 3.8 meters high, that's pretty high. I just realized that. That won't be that won't be useful in a playground, maybe in Luna Park or other place. But anyway, oh, that's very dangerous, 3.8. Okay. All right, do not try this at home. All right, supporting the 3.8. So find the length of the slide. So to find the length of the slide, you're going to find h, all right, hypotenuse. So what do? We just go, this is opposite, this is hypotenuse, so we're going to use sine. So sine 41 degrees is equal to 3.8 over h. And to find the value of h, you just multiply both sides by h. Okay, like that. And then you end up getting h sine 41 degrees equal to 3.8 meters. And then to find h, just divide 3.8 by sine 41. Correct your answer to, doesn't say, maybe to the near, one decimal place. Forgot to write that, one decimal place. Okay, do that. All right, use your calculator. Nearest one decimal place. One decimal place. Okay, good. So do that on your calculator. 3.8 divided by sine 41 is equal to 5.8 meters. Approximately 5.8 meters. Right, not too difficult. Just have to draw the diagram. The next one, diagram's given, but the question's a little bit harder. Have a think. Have a think. Good. All right, good. So this one is a bit harder. You may have to set up two equations. So you have to find the value of theta. So to find the theta, I need to know the total length, isn't it? I know you got 200, and that's not a right angle triangle. So what we need to do is find out the bottom length. And to find the bottom length, you just have to find out the shorter length. Let's call this x. So to find x, you go 50 over x equal to tan 75. Okay? So therefore 50 equal to x tan 75. So therefore x equal to 50 over tan 75. Alright, find out what x first, then you can find out theta. Alright, good. So work out. Now I'm going to leave it as it is because that's going to be exact. Try not to round your answer in the middle. So what you do is, then the bottom length will be 200 plus 50 over tan 75. And then what you do is to find theta. Actually, that's going to be annoying. So maybe what we do is just work out on the calculator, correct to maybe two decimal places. So you go 50 divided by tan 75. You get 13.394. 13.394. 394. 397. Okay. 397. 97. Okay, and then what you do is if you add it together, you get 213.397. And to find theta again, you go tan theta of the big triangle. You get 50 over 213.397. And then maybe just use this part. So what you could do is just add 200 to it. You get this number, and then to do 50 divided by your answer, which is this, and then press Shift Tab, answer. 13.186. Theta equal to 13.386. Maybe to the nearest minutes. So press this button here, 11 minutes. So 13 degrees, 11 minutes. All right, any questions? Oh, let me try again. 50 over 1075, right? So, yeah, that's 75 degrees. And then you add it to 200, divide 50 by 200, get 0.234, and then shift hand to get the angle. Yeah, that's just the ratio, but not the angle. So the one before that will be 0.234. 0.234. And to find the angle, you have to shift hand. All right, all done. Thank you very much. So now what we need to do is to, 13 degree, 11 minutes. You need to do some